Hi, my name is Guang, 12 years old. For this lesson, we'll be continuing on with another lesson for methods of limit calculation. For this method of limit calculation, we have another example here where we are given limit x approaches to 1, 2x squared plus ax plus b over x plus 1 is equal to 3. And we are supposed to find the values of a and b. So over here, what we have is this question, finding a and b, right? So like the previous lessons that we have done before, we're going to use three methods. So over here for our first method, what we have here is method 1. Which is the L'Hopital's rule. So for this part, what we have over here for the L'Hopital's rule, what we are going to have is that, first of all, let's check the denominator. So the denominator over here, x plus 1, and then, so x is equal to -1, right? So -1 plus 1 is 0. So supposedly the denominator, if you just straight away sub it in, it's going to be a 0. And thus here we have L'Hopital's rule, so we are going to have a 0 over 0 scenario for this part, where we are going to use the L'Hopital's rule. So when we use the L'Hopital's rule on the denominator, what's going to happen is that this will just become a 1. So you can just ignore it because that anything over 1 is just itself. And what we have for the numerator will be 2 times 2x, whereas you have another 2 in front, which becomes 4x, and then 4x plus a. And if you substitute x inside, what's going to happen is that you're going to get a result of a minus 4. And then what is a minus 4 equals to? 3. And since it's like that, a is equals to 7. And then here, because of this 0 over 0 scenario, this part above is supposed to be equal to 0, right? So we are going to let limit x approaches to -1, 2x squared plus ax plus b. So this is supposedly equal to 0. So for this part, what we'll get here is that this will be equals to, so here we'll have 2 plus, and then there's -1, and then here you have 7. So instead of plus, it will be minus 2 minus 7, then plus b is equals to 0. And since it's like that, b will be equals to 5, and thus we find out what a and b are. And now that we have finished our first method of L'Hopital's rule, we'll be moving on to our next method. So what we're going to have for the next method will be factorization. You might be wondering, how are we even supposed to factorize this if we can't even separate it into two parts? Well, we can separate it into 2 parts. It's just that we're just going to have one extra variable. So what we're going to have here is that, obviously one part that's separated is x plus 1, so we can simplify. But the other part that we separate, how are we supposed to know what it is? So why not we just name the part like x plus c or something like that, and we'll decide on what c is later. But over here, if you continue for this part, you'll realize that over here, you're supposed to have the 2 in front of this c, because for this part in front. And now that we have gotten till this, we can simplify the 2 for x plus 1s. And what we're going to end up with here would be 2x plus c, and then x approaches to -1. So what we are going to have here now is that this is equals to, so you substitute c minus 2 is equals to 3, so c is equals to 5. And now we have to find for what a and b is. So what we have is that, so we let 2x plus c x plus 1 be equals to 2x squared plus ax plus b, and then so for this part, what this is basically is 2x plus 5 times x plus 1 is equals to 2x squared. So what is this equals to? So if you are to just straight up times it, what you're going to get is 2x squared plus 7x, then after that you're going to have a plus 5. And since a is for this ax, so a is the coefficient for x, while b is just the straight up the constant. So over here, so a will be equal to 7 and b will be equal to 5. So here you have it, our second method of factorization. Now moving on to method 3, we have partial fractions. So for method 3 of partial fractions, we're just going to do it by each for x squared and x, then yeah. And then that's all, because that we only have these two that we have to take note of. So partial fractions. So what we're going to have here is that, so we have limit x approaches to -1. So once again we copy down the question. So what we're going to do now is that, so over here we have x plus 1, right? So why don't we have limit x approaches to -1? So over here we're going to plus has 2x minus 2x. Well, what's the point of doing that? It's so that over here, if you see for this part you plus 2x, you're going to realize that this part, if you take a 2x out of these, is what you're going to get in the end is a 2x bracket x plus 1. While what you're going to have afterwards, you have to minus the 2x. So here you're just going to get a minus 2x plus a b. And now that this part's over, for this we can take out the 2x, which we're going to have a larger bracket, and here we have 2x, then 2x plus a minus 2x plus b over x plus 1. But now that we have gotten for this part, this you can straight up substitute inside without having any trouble. So you're just going to have a -2 then plus. And now for our next part, once again we plus something minus something. But what are we adding and minusing now? So we're going to add a minus 2. So here we're going to have a minus 2x plus a minus 2. Then after that plus b minus a minus 2, whereas it's going to be a minus a plus 2, and then the denominator is going to still be the same. And now we can take this out. We don't have to put this extra bracket anymore, because that once you take it out, there's no more x. So you just get a -2, then after that plus a minus 2, limit, then plus limit x approaches to -1, and you have b minus a plus 2 over x plus 1, and this is equals to 3. So what you can tell from this part is that, so over here you can tell that this part must be equal to 0, and thus you can have an extra step if you want, whereas because that you know that this cannot be equal to 0, so this extra step will be a minus 4, by putting these together, will be equal to 0, and thus you can tell that a is equal to 4, and since this part is supposed to equal to 0, or else it will equal to infinity, which we cannot get it. So over here what we're going to have for, whoops, it is equal to 3. So this will be 7. And thus for this part, b minus a plus 2 need to be equals to b minus 7 plus 2. So b minus 5 is equals to 0. And thus b is equals to 5. And thus we get the results for our a and b for all three methods. So we have our L'Hopital's rule, whereas we will have a 0 over here, since the denominator is definitely approaches to 0. Then after that you can find out what a is, and by finding out what a is, you can find out what b is, because over here, in order for the 0 over 0, the numerator also has to be equal to 0. And for the second method, we basically factorized this part into two different parts, and then after that we have an extra variable that we find. And once we found this variable, we will substitute inside and check the coefficients and relate it. While the last method we used was just partial fractions, whereas we just took each part out from the x squared, where we have the 2x becoming negative 2, and then we take off all the a minus 2 bracket x. Then after that, for this part, we'll have this part, the a minus 2, and we will have the last part, which we cannot take anything out. And once we get there, we know that this part, the denominator is 0, so this approaches to infinity. Well, the numerator the numerator will have to be equals to 0, so that this part will become 0, and we can get our result of 3 here. And by doing that, we find out what a is, and we can find out how this part over here is equal to 0, and thus finding out what b is. So over here we have these three methods. Take a quick look. Now that this lesson is over, last but not least, thank you for your watching.